Okay, so here's a video on something called Rolle's Theorem. And Rolle's Theorem is invented by a guy who was a French mathematician, the last name of Rolle, hence the name of the theorem. And he kind of came to this conclusion that if you have a graph, so I made up a graph here, and you're studying it on an interval, let's say from A to B, and you know three things are true. You have a function on this graph, we'll call it f of x. And this function that we're about to graph is continuous. So I'm going to write over here, is continuous. You know that for sure f is continuous. You also know for sure that f of x is derivable, it's differentiable. And you also know that f of a is equal to f of b. These are kind of like the three menu items for Rolle's theorem. Like, you have to have these three things. The function's got to be continuous, it's got to be differentiable, and f of a equals f of b. And what all these mean on a graph is this. F of a equals f of b. This piece means that over on the graph, wherever a is, I'm going to make up a point, b has got to be the same. They've got to be the same y value on the axis over here. So doesn't matter where they're at, we just know they're the same. If we know the graph is continuous and differentiable, well, what that means is, if we know this, then there can't be things like holes, asymptotes, sharp corners, we call them kinks, can't have any of that weird stuff. So it doesn't matter how you draw your graph. You can make up your graph right now. You're going to connect A to B however you feel like. And you could get very creative. You could go up, go down, make a parabola. You could go like all over the place. If you wanted to change it up, you could do something like this. You could go way up here, way down here. It doesn't matter how you connect the points, as long as when you're drawing your graph, you don't make any sharp corners, no kinks, because then it wouldn't be differentiable, and you don't make like an asymptote or something like that. You don't have one of these scenarios. That wouldn't work. And you don't do something where there's a hole, because that would be not continuous. So as long as you avoid those situations, let's just draw the graph kind of easy, like that. Now I'm looking at a graph. I'm going to call this thing f of x. And it's continuous, it's differentiable, and f of a is equal to f of b on the graph. Here's what Rolle's theorem says. Sorry to be kind of lengthy about this, but his theorem says that if these three things are true, then there has to be a point on the graph, we'll call it C, where if you went to the graph, you could find a slope of 0 for the tangent line. There has to be one point at least. There could be like 5 of these, but there's got to be one point where if you derived it and found f prime at C, the slope of the tangent would equal 0. And logically, doesn't that make sense? Can you think of any way you could draw a graph that goes from point A to point B and doesn't have a slope of 0 somewhere? Try drawing like 5 graphs. You'll find out every single graph you draw, if it has these things, continuous, differentiable, then you won't be able to make a graph that doesn't have a slope of 0 somewhere. So that's Rolle's theorem. So to kind of state it how we have it worded in our textbook pretty much, it looks like this, and I would write this down. If f of x is continuous, that's a key part of this theorem. If f of x is continuous on a to b, differentiable on a to b, and f of a equals f of b, then there is at least one value c such that f prime of c equals 0. So there's got to be one spot on the graph where the derivative equals 0. Now it's possible there's like 6 points where this could happen, but there's got to be at least one. And what I mean by there could be at least 6 points, I mean this. Let's say we set up a graph here, and we know f of a, so we're going to say this is a, that's a bad looking a, this is a, and this is b. F of a and f of b are equal to each other. I'm going to connect this graph however I feel like, so maybe this time I'm going to go like this. Well, now I'm seeing there is 1, 2, 3 spots where the derivative is equal to 0. That's okay. Rolle's theorem says there's got to be at least one. So this time there's 3. I could have made the graph crazier and made like 6 spots where it was flat. So no matter what, there's at least 1. That's Rolle's theorem.